Well, hello there, folks. I hope you're doing well. In this video, we're going to be talking about Chapter 7.6, Parallel Lines and Transversals. If you're following along in your workbook, which you should be, of course, this starts on page 200, and you're going to need a protractor. Sorry, you're going to need a compass. You don't need a protractor. You're going to need... No, I got that backwards. You're going to need a protractor. You won't need a compass or tracing paper. First, we start with the try these. Name a pair of opposite angles. Well, opposite angles are angles that are on opposite sides of intersecting lines. So one example, there are two options. No, there are two options. Angle 1 and angle 3 are a pair of opposite angles. The other pair is angle 2 and angle 4. And then name a pair of supplementary angles. If you recall, a supplementary angle or supplementary angles are two angles that add together to be 180 degrees, or two angles that go along a straight line. So there are, this time, 4 options, but let's go with angle 3 and angle 4. So these two angles put together will make 180 degrees because they lie right along a line. Now let's use some of the information we've learned so far. This map of northern Alberta shows Highway 56 and Highway 854 are parallel. Highway 13 intersects both of them. So these two are parallel. This is a transversal line. When you have two parallel lines that are being intersected by a transversal, you can get some really important information. So let's figure out these important things. First of all, name pairs of corresponding angles listed on the diagram. So corresponding angles are angles that are in the same position on opposite parts, I guess. Opposite, on the opposite lines, or whatever you want to call it. So let's do that. The first pair is going to, we'll start with 1. So its corresponding angle is the one that's in the corner in the top left, which is 5. So angle 1 and, sorry, that looks like a 4. Angle 1 and angle 5 is our first pair. Angle 2 matches up with angle 6. So angle 2 and angle 6. Angle 3 matches up with angle 7. Angle 3 and angle 7. Oh, I'm getting too much space. And then finally, angle 4 is going to match up with angle 8. So angle 4 and angle 8. Compare the measures of the corresponding angles in each pair. What do you notice? Well, let's bring out the handy-dandy compass, or pardon me, protractor. And you should do it too. So put the protractor on the corner. Let's just start with angle 1 and angle 5. Wow, I got my protractor backwards. Let's try this again. So I put my protractor right along the line. I check that angle, and I find it's, about 58 degrees, maybe a little more, a little less. 58-ish degrees. And then I check my other one. Oh, it was 55 degrees. 55 degrees. I put my protractor in the wrong place. Lo and behold, you know what? No, it's 62 degrees. I'm sorry. I'm trying to use the computer. Using my protractor earlier, I found that it is indeed about 62 degrees. So if you put it there, the angle 1 is 62 degrees. The angle 5 is 62 degrees. The important thing is that these corresponding angles, they are the same. So if I have a transversal running through two parallel lines, the corresponding angles are identical. Now, the second part says name the alternate angles labeled on the diagram. First of all, we have the alternate interior angles, and then we have the alternate exterior angles. I'm going to try and make it so that these are visible. Can't really do it successfully, unfortunately, it looks like. Try really hard. Oh, there we go. We can just barely fit them in. So I'll clean up my lines. Whoa, what have I done? clean up my lines, and go back to doing it. So our alternate interior angles, if you remember, if we start with number 3, the alternate interior is the one on the opposite, angle 5. So I have angle 3 and angle 5. And then we have angle 4, which is angle 6. So angle 4 and angle 6. And our alternate exterior angles, same thing. So angle 1 is going to match up. And oh, there's a hint here. Alternate interior angles and alternate interior angles form a kind of Z shape. Our alternate exterior angles don't really have as fancy of a thing. Anyway, so alternate exterior angles, we have angle 1 and angle 7. And the other pair of alternate exterior angles, we have angle 2 and angle 8. If you measure them now, you'll find something interesting. You'll find, if you measure them, that once again, they are the same. What does that mean for you? It means that if I were to get, for example, just one measurement, if I had just one measurement of these two parallel lines with a transversal running through them, if I had angle 1, due to these rules, that means angle 3 is the same as angle 1, angle 5 is the same as angle 1, and angle 7 is the same as angle 1. If we go over to question 6 now, or part 6, it says measure the angles 1 and 8 on the same side of the transversal. What do you notice? Well, if I measure, or sorry, first of all, measure 4 and 5 on the interior angles of the transversal, what do I notice? So if I measure angle 4 right here, I am going to find, maybe it'll cooperate this time. Maybe it'll cooperate this time. Maybe not. I will find it is approximately 118 degrees. And then if I measure angle 5, I find that it is approximately 62 degrees. So it's 118 degrees. Wow. And 62 degrees, which add to 180 degrees. So they basically make a supplementary angle when added together. And if I measure the exterior angles of angle 1 and angle 8 now, over here, I find the same thing. Angle 1 is 62 degrees, angle 8 is 118 degrees. So they also add to 180 degrees. Which means if I have, looking at this example once again, if I have just one of these angles, if I have angle number 1, for example, because of the rules of these parallel lines that are with a transverse line going through it, or a transversal going through it, I know that 1 is equal to 3, and 5 and 7, and that 180 minus 1, or angle 1, 180 minus angle 1, is equal to 2, which is equal to 4, which is equal to 6, which is equal to 8. So with one angle, you can find the 7 other angles. And that's where the power of this comes in. And also they have some shape, again, some shape hints if you're trying to figure out which is which. Let's do an example now. How can you determine if range road 183 is parallel to Highway 854. Are the measures of the corresponding angles equal? So if I measure I have this angle here and this angle here. If I measure my corresponding angles, which are going to be 7 and 6, I find out that yes, they are equal. The corresponding angles are equal, so the roads must be parallel. That's the rule. If the corresponding angles are equal in two lines that are intersected by a transversal, then the lines are parallel. What is the relationship between corresponding angles and parallel lines? Well, if a pair of corresponding angles are equal, then the lines are parallel. Or, the other way around, if the lines are parallel, the corresponding lines are equal. We can then go on to D. What is the relationship between alternate angles and parallel lines? If a pair of alternate angles are equal, then the lines are parallel. Or if the lines are parallel, once again, then the alternate angles, those guys, are going to be equal. So my alternate angles, here I have, I always get these guys backwards. So I have to look at my, always have to look at my notes here. So I have this one right there is an alternate angle, or its alternate angle is 5. This one here, its alternate angle is going to be 8. Anyway, so they are equal, which means the lines are parallel. And if the lines are parallel, then those alternate angles are going to be equal. Finally, what is the relationship between interior angles and parallel lines? Well, if my interior angles, so once again, looking at, pardon me, no, don't want to do that. Looking at this inside angle here, its interior angle is going to be this one right here. So these, if you add them up, are going to add to be 180, which means they're supplementary. So if a pair of interior angles are supplementary, that definition's up here in your textbook if you want to look, or not the definition, the proper spelling, because it's kind of messy, then the lines are parallel. Or if the lines are parallel, the alternate angles are supplementary. What does this mean? Well, at the intersection of Highway 854 and Highway 13, there's two pairs of opposite angles. What can you say about the measure of those opposite angles? Well, according to our rules, since these lines are parallel, the opposite angles are equal. So 854 and Highway 13. Sorry, let me just clean it up so we have a good look at it one more time. So my opposite angles, once again, are 5 and 7 and 6 and 5. So 5 is equal to 7. Angle 5 is equal to angle 7. Angle 6 is equal to angle 8, which means the opposite angles are equal. If I add them all together, well, 5 and 8 are supplementary, so they equal 180. 6 and 7 are supplementary, so they equal 180. 180 plus 180 equals a full circle of 365. 360 degrees. So I'll even write that. They all add to 360 degrees. And that's it. That's it for 7.6. So once again, another kind of concept-heavy chapter. Make sure you look at the notes that you've written while trying to do your examples. But if you run into any problems, have any questions, please let me know. I will do my best to help you out. I hope you have a fantastic day, and I will talk to you later.